Hi, my name is Arnav, and I'm going to talk about my image captioning project. In this project, given any image by a user, the app will output a description about the event of the image. For this project, I've procured the images and captions from the Kaggle Flickr 8K dataset. There are around 8,000 images in the library, and each image has 5 captions. These captions act as labels for the images. For example, the image shown below left has 5 captions as shown on the right side. For this project, I divided the entire data set into a training set of 6,000 images and a testing set of 1,000 images and around 8,500 words. In this project, I use Inception V3 for images, which is a convolutional neural network architecture or a set of algorithms that represents the culmination of advancements in computer vision within a deep learning. Its main purpose is to take objects in an image and assign values to it. The figure below shows the architecture of a CNN, which has 3 layers: convolution, pooling, and fully connected layers, where in the convolution layer, filters are applied to extract features from images. The most important parameters are the size of the kernel and stride. Pooling layers, its function is to reduce the spatial size, to reduce the number of parameters and computation in a network. Fully connected layer. These are fully connected connections to the previous layer as in simple neural network. For an optimal CNN, we had to consider some pre-trained model Inception V3. As Inception networks have proved more computationally efficient, both in terms of the number of parameters generated by the network and the economical cost incurred in terms of memory and other resources. The figure below shows the architecture of the full Inception V3 model. For our purpose, we removed the last 2 layers of the full Inception V3 network. Therefore, there are 312 layers in our model. LSTM is a recurrent neural network, or RNN, which is composed of long short-term memory units and is often called an LSTM network. A common LSTM unit is composed of a cell, an input gate, an output gate, and a forget gate. There are connections between these gates and the cell, as shown in the figure below. The expression long-term, short-term refers to the fact that LSTM is a model for the short-term memory which can last for a long period of time. For a bidirectional LSTM, the inputs will run 2 ways by duplicating the first recurrent layer in the network so that there are now 2 layers side by side. The input sequence is provided as an input to the first layer, and the reverse copy of that is provided to the second layer. This increases the number of parameters, but also increases the accuracy of the model. I divided the Flickr 8K dataset into separate folders of image and captions, and then mapped these to each other. This created a dictionary with the images as keys and their values, a set of 5 captions. Since Inception V3 requires the input images to be in a shape of 299 times 299 times 3, we converted each image into a 299 times 299 times 3 pixel representation. Out of 30,000 captions for training, in considering words, which occurred at least 10 times, we reduced the vocabulary to 1651 words. For word embedding, we used Glove to convert words into vectors, and we found 400,000 word vectors. After preprocessing, the data is fed to 2 parallel components as depicted in the model. The process input images are passed through the Inception V3 model, where features from the image are extracted and are in the form of a flattened array. Parallelly, the caption data for the training images is set to the RNN. This model takes data from the captions with respect to the words used and their frequencies. The output is fed to a decoder which maps images features to information extracted by the LSTM. Thus, features and images are associated with words and captions to train the model, which is summarized in figure below. To evaluate the model, we use BLEU, or bilingual evaluation understudy score, which compares the candidate with a reference translation and counts the number of matches. The more matches, the better. After preprocessing, the Flickr 8K dataset provides data in the form of a dictionary where the key is an image and the value for the image is a test of 5 captions. The BLEU metric is used to do a best match from all the captions and shown as the caption. Now let me show you a demo with some images. First things first, I'll make sure the app is on. Let me choose this image. So this one says a man in black shirt is sitting on a bench. This one here says man in black shirt and tie is standing next to a person who is wearing black shirt. This one says a group of people are writing at tables. This one says man in black shirt and hat reads book. As you can see in this demo, the application can be refined further and generate more accurate captions for various use cases like medical images, X-ray captioning, storytelling, helping visually impaired people, or acting as a virtual assistant, and much more. Thank you for watching. This is Arnav with a guidance from my instructor, Stella Hou.